Hope you're having a very good day since morning. I think we have a mixed crowd, right, of SREs, developers, and engineer students, graduates as well. So, what is the challenge in front of us as an SRE, right? So, I usually get a call from my boss or clients, or sometimes a page duty alerts at the midnight of the day, right? So, the first challenge in the morning during postmortem, the question we get is, how did we miss? You guys get the similar questions from your boss? Most of the time, right? And the next challenging thing is, did we monitor? Right. So most of the time, the common challenge here is our applications in front of us are too dynamic. We just talked about AI agents, right? So it's making us more complex, right? So if AI agent, the Gen AI, gives some response for a prompt, we don't know what makes to give that response, right? Even if you give all the RAG, all the training, all our data, observability data and everything. But still, we need to know why that gives, then only we can make the next step. So we are still in the era of all microservices architecture with like thousands of microservices, talk to like legacy systems, still mainframes. And now I put that open telemetry has good amount of investment and start creating an agent, open telemetry, SDK for mainframes. At least we get some visibility because still you have to live with mainframe for some more time, right? And also some of the legacy ERP systems written in C, C++. So still, whatever we need to gain visibility to know what is going on to quickly solve the problems, right? And the other one is like business critical. This is apart from the technical challenges, we have to answer the business people as well. So if technology is not helping to solve the business needs, then obviously during the like Black Friday sale or during the IPL match, if the system like streaming services or the retail platform is down, obviously business is not going to be happy and we have to solve their problems as well. So that's where we are going to see where the human-driven SRE meets the AIOps, right? So that is Observability 3.0 in our point of view. So just to touch upon why do we need this observability? How does it evolve from our traditional monitoring, right? So how many of you are tracking these, MTTR, we have a target. How many of you tracking MTTD? Very few, right? So that is very important to find out, do we have a good observability system or not, right? So whether the incidents are raised by the tool or is somebody still taking a phone and calling the call center people and okay, this is not working, that is not working, and the volume is high, then engage the war room and stuff like that, right? So this is very important. Further down, the mean time to isolate. So this is very important as an SRE who actually sits in the war room, troubleshoot, right? How good our observability to tell us where exactly the problem, right? Out of these 1,000 microservices, that's one microservice causing this problem. So that's where everybody is in the bridge, 20, 30 people troubleshooting. So it's MTTI. We need to start measuring this as well to understand how efficient our systems are and engineers know about the system. So why the key differences, I think I'm not going to spend much time. So let's go to the revolution of observability, right? So obviously we want to see the system itself has to emit what state it is in so that we can clearly know where the problem, and the problem is engineers spend more than 50% of the time in finding out where the problem is. Even the developers, right? If the testers finding a bug and giving to them, definitely they're going to spend a lot of time in triaging rather than implementing a feature. So every incident will actually pull us back, will not allow us to move forward with new features, because if system is not reliable, our leaders are not going to approve to put a new change or a new feature. So that's when we have to have a good, reliable, robust system. And the solution is we need to have a quickly detect and resolve and triage issues. Okay, so before getting into 3.0, just to give a glimpse of history, right? What the foundation, when this all started with 1.0, so what are the key things we had? So the early distributed system, when we moved from monolithic to distributed microservices architecture, so we thought of we'll get more visibility. So from traditional CPU memory disk utilization to some more metrics like throughput, rent metrics, we call it as the error rate, latency. But still, is that enough to monitor, right? The reality is no. Because even though we collect all these metrics in an isolation where it has a limited context. So suddenly if there is we getting an alert, like the latency is short up, we usually come back and find in milliseconds, suddenly it's coming up in 5 seconds. Why? So we don't have a context. That's where we saw all these open telemetries with cardinality, throwing all those metrics, attributes and all. But still, it has some of them are limited context in the initial set of observability phase. And slow resolution, obviously, because we don't have much visibility into all systems. And it's all reactive. So we don't address those problems, like we don't do shift left. So we just react only after the incident happens and start learning from there. And it's all manual, right? So we had some set of automation through shell scripts or Python or PowerShell, whatever, but still, it's mostly the recovery or manual. Still, people go and do the manual rollbacks, though we talk about DevOps for more than a decade now, but still a lot of manual rollbacks are still happening. Okay, so the rich telemetry signal, this is where we introduced. So we saw metrics melt, right? So melt was started from the beginning. Then the open telemetry realized that both logs and events are like similar signals, right? Both the key value pair. So what is the key message at what time and what user faced the issue, what are the additional parameters, right? So they combine these logs and metrics as a single signal. And apart from these, profiles are introduced lately. The performance engineers, we do code profiling earlier. So we just to find out what the dynamic paths that the code traverses through, to find out all the resource bottlenecks, say like CPU, memory, or even the network bottlenecks as well. But here in production, in the continuous scale, to collect these metrics, so further troubleshoot the problem. So when we get a pod crash looping or a pod restart alerts, if you go and look at the Kubernetes, it says, I am killed, right? We just simply ignore that sometimes. We don't know how to troubleshoot. That's where these profiles help, especially with this Linux eBPF, which provides continuous the flame graphs of what is the snapshot of what is happening in the runtime. So that really helps at what is a leaking object, and so that we can put a permanent fix for that, right? So that's where they introduce the profiles as one of the signal. And finally, the recent ones are like a user signals, right? So most of the other four are completely a technical side of things. So all the backend systems, but how the user is experiencing, right? So we call it as a RUM or a business events, but still how the user is experiencing at the end of the day matters, right? So if the user is not happy with the social media, they are going to just put a bad comment on the Twitter and all other places to reduce the brand value, right? So that's where adding another user signals to help understanding how users are seeing it. So the context, right? We talked about context. So I want to spend a little time here. When the services talk to each other, so does it pass the context? So that is very important, right? For example, I'm receiving a request to place an order. So if I don't get what is the product or item in the cart, during the payment side, what is the amount and what is the user, what is the transaction ID. So if you don't pass those contexts across the layer, then it's very hard to find out if there is a payment failure. So the payment failure for which user. So that level of detail that we need to get in the entire topology. So some of them related to the domain, right? So specific to whatever the payment domain, or is it like orders, or just a card, or is it like a medical? So bringing more business attributes to what the data that we are sending, so that gives us more context when we are doing a troubleshooting. So now with these pitfalls, whatever we've seen in the observability 1.0, so that's where the tools and even the open telemetry, they evolved and they build the next era of observability. That's where instead of reactive firefighting, they do a proactive optimization through these shift lefts, doing observability-driven development. We've seen that asking developers to add couple, instead of doing just log.info, just add couple more attributes as well to trace down the request, like a trace ID, like a context propagation. So those are some of these additional things that the developers help to add more instrumentation there. And that's when the unified and cloud native picture came in, right? So initially we had a siloed data. So where even in most of the customers that we work, at least they have minimum 3 tools. Even the commercial ones, like they have a Splunk, they also have a Dynatrace, right? How many of you have more than one observability tool in your project? Good, rest of them have only one. So I see only 3-4 hands. That's good. So at least the problem is if we get more metric in one place, there's a log in another place, and the application sends in another place. So it's very hard to troubleshoot, right? So that's where the drawbacks of siloed data and observability 1.0. So the unified single source of truth really helped not only the SRE engineers to make the problems faster, but also the recent AI agents, which can actually help learning the data and not only troubleshoot problems, but also helps business to provide insights where to focus, right? So if the users are, for example, if it's an e-commerce, right? If users are liking more kind of products, right, which with the insights that it gives, definitely business can invest more on bringing the varieties to that product. So it really helps us to have a unified, a single source of truth. And the other problem that we face is, so we have a weekly and monthly review with our product team or business, right? So we just present all our metrics. Okay, our system is 99.9% up. The availability and reliability is good. So customer happiness score is like 90%. But when you go and present product, first question we'll ask is, they have a thing called NPS. Do you guys know what NPS is? Net Promoter Score. Yeah, they usually come up with the number says it's only 50%. Customers are complaining, but you're showing all greens, right? It's like a watermelon status we show, right? We show everything green, but inside it's all red. So the problem is the business sees some other data that as a technology engineering team, we see different data. So that's where the single source of truth is always important. So that's where bringing all data together, including the user experience metrics, and so that we report the same data to everybody, so there is no difference of opinion. And AI-powered intelligence, we enough talked about it. And the predictive insights, so this is another important with the historic pattern, providing these data to learn and prevent. I don't think it's going to prevent events in the system with the historic data. It's going to prevent incident is going to happen in next 30 minutes. But still, at least provide some sort of alarming with based on the different signals. So it's going to fail based on the symptoms. Okay, now, so we talked about covering all the gaps, right? So instrumenting all the black box systems, including the mainframe legacy systems and everything. We bring all the data in to a single source of truth with everything in there. Is it good enough? So for engineer or AI system to find the problems and solve, is it good enough to improve the reliability? I don't think so. Because if you look at it, so once we bring all the data, I think we've seen earlier as well, the only 5 to 10% of telemetry data that we bring in is being used, right? I don't think rest of all the logs, debug or error, until somebody reports it that there is an incident, nobody's going to see it. So it's all, we pay enough to the cloud provider for the storage, network and everything. I don't think it's being used effectively. And this is Gartner report again, I think we saw in the morning. So around 36% of their customers pay more than $1 million per year in observability tools, right? And also some of their Fortune 100 customers pay more than 10 million because obviously, right, Splunk, Dynatrace, all those costly tools, if they have 2 or 3 tools, definitely it's going to cost more. So for better reliability, we have all these. What are the things we need to do? Right? So human-driven SRE, so as Clarence rightly said, so AI agent is not going to replace the humans, right? So it's going to help human. They are the co-pilots. So we ask questions and they actually really help us to troubleshoot issues faster. And pragmatic AIOps is again, not like we just go blindly with what tool says. We just have to have an evidence, right? When we say SRE, we are completely a metric-driven engineering team, right? So we just rely on metrics. So if the MTTR is high, or if our turnaround time or the latencies are low, so we're not, if user complains, we still go and verify in the system, right? So we need to have a pragmatic way of approaching problem and fixing it. An active decision system, that's where again AI can help here with the historic incident data. So really help us to make a proper decision in terms of business as well as in engineering approaches. So these are some of the human-driven SRE elements that you guys start anyway measuring it. The service level objective is the foundation of it. The failure hypothesis, how many of you doing chaos engineering in your organization? Very few, right? So that is again important things. That's where you have to start thinking the failure hypothesis in every feature that we are rolling out. So that really helps us to find where are all the single point of failures in the system or what can go wrong so that you don't have to work on this with the war room and have to answer all the leadership, right? Anticipate those and start designing the systems and also start practicing chaos engineering to find those problems early in the life cycle, right? And the tolerance level, again, this is like a capacity benchmarking to make sure not only we have an auto scaling in place, but also we setting up a right scaling, right? Are we measuring the right capacity or right number of pods are there? And document the system. That is really important for even if you put an AI agent, it needs to learn, right? So we need to have a proper RCA because I don't think we say that we do 5 analysis, but none of the postmortems that we document there. So it's very hard, even if there is similar incident happened in the past, we go and search, it's not going to be helpful. So that's where human-driven SRE really helps for manual as well as AI-based operations there. I think the explainability is like already we discussed. The guardrails is very important, right? So what kind of data and what kind of access we give it to AI, and make sure that this is the common, you would have all started practicing these building AI agents, right? So one of the things to make sure is we should not give access to the public models about whatever the organization data, right? So that you might have a different policy in every organization, but make sure you have guardrails when MCPs connect to our tools. The models, right, they're probably self-hosted or like dedicated to the cloud, Bedrock or AWS Azure, so private to that particular organization. And post-incident learning, this is again continuous improvement. How can we avoid this happening, right? So one of the key things that we measure is the repeated incidents is one of the attributes that we measure. So if the incidents keep coming, so that's a pattern, right? So we have to start understanding why that is happening. Did we put a permanent fix here? So that's where we can start enforcing policies. If a team keeps getting those incidents and they still keep releasing the feature but not fixing the backlog, there is no point. That's where we started enforcing change log policies for such teams to avoid the deployments from those, to just at least guardrail to make sure the system is reliable. Now, human side, we've started what is on the AI side, right? So where Clarence touched upon a little bit, I'll also cover the correlation is the key thing in the MTTI, right, to isolate. So we have plenty of metrics coming in, million metrics from all 1,000 microservices. We just have to do auto correlation to find where exactly is the problem and detect the anomalies at the right time and avoid these event deduplication, so that we actually, one of the ways is like a composite alerting. So composite alerting really helps instead of throwing 5-6 incidents at the same time or creating same alert. So if it's related to a same incident, group it and give it to one simple composite alert to act upon. And LLM powered triage is through AI agents. And if you all do automation, it's there from the beginning, right? Runbook automation is the straightforward one. If you have a clear SOPs documented until the permanent fix come. Again, runbook automation is not a recommended solution for a prolonged duration, right? So if a same SOP is being written again and again, then we are not doing something correct, right? If an incident comes in, then automate the same recovery process, then we are not putting a permanent fix there. So that's where use it for until the development team takes their own time to address those permanent solutions. And safe auto remediation, this is again self-healing. So look at the design patterns like circuit breakers, retries, so that instead of handling the operations team dealing with the runbook automation, let the system itself recovers on its own. Okay, now let's talk about these telemetry pipelines where we bring in the data, right, from all these systems. So when we collect from all the sources, so make sure when we are building this AI system, there is a thing called feature, right? Feature is nothing but the unique characteristics of a model, right? If you want to feed in some of the data, let's say resource utilization, the CPU utilization is one of the feature, right? So that we feed in so that it can predict when it's going to fail, right? If it's going to load comes in, CPU is going to increase. So make use of these relevant metrics and send it to feature stores for ML model to train. And basically keep improving the model by retraining, right? This is the model that we build for our own kind of systems and the data. Knowledge graphs, this is very important from if you're building an AI system for automation. So where mostly we use a different kind of data, right? So in the distributed tracing, where if you look at the service map, it automatically based on the trace ID, trace header, it builds a service B, service C, and the talks to database, where it automatically builds in the system, and when an anomaly comes in, it knows what system, where it broke and everything. So that's very important in building AI agent for SRE. And it also helps to predict the failure propagation path. So let's say if the database goes down, if 10 microservices depends on it, so it actually predicts that and start alarming those, giving a warning signal, so to make a preventive action to it. So feedback loops are important. I think in an SRE, we always follow that. So get that feedback not only from an incident perspective, but also model prediction perspective, how accurate it is predicting, and start providing more data to train them. I think governance, we've seen that. Okay, yeah. what are those common pitfalls, right? When we use this AI and human-driven SREs. So data depth is one of the critical thing, right? So where poor data quality definitely not going to help us improve. So even if let's assume that we have 100% coverage there. So some new feature comes in and that somehow breaks the chain of observability. They don't pass the context to other services. So we'll definitely miss the data. So training with such a data definitely not going to help in solving the problem. So we have to make sure that we provide right data for training. And alert fatigue, like too many alerts, too many false positives is not going to help. So we have to find out those and rectify that. And overfitting to incidents. So if we keep training with the past data, if there is a new pattern of incident comes in, so it may not provide you the correct accuracy. You have to make sure that you have to feed the new patterns as well. What kind of anticipating new failures, right? So just feed that as well. So to roll out this model, just always start small, prove value. What is the ROI, right? So this needs large amount of investment in terms of engineering efforts and also the tool investments, right? So prove the value. What is the ROI that we are going to get if we implement these AI agents? And scale gradually, start with one feature. So that's how we started for us. One of the common problem, we always have to watchful of where the money goes, right? So where it's in the payment gateway side. So put some agents there to detect what is the amount of time that takes to complete the payment, or what is a failure, what is it a legitimate failure or is it a technical failure. So put those areas in, start gradually and expand it to other domains. Measure the impact and continuously improve. Okay, so now we have seen 1.0 and 2.0. I don't know if Shankar is going to take Kuti 3.0, but based on these, right? So observability 3.0 in our point of view is, first, lower the observability cost. That is very important because as we've seen the percentages, so we are at like 10 to 20% of total infra cost. But first thing to focus on what is really important, whether send only the meaningful data, which is going to help humans and as AI agents to troubleshoot the problems quickly. AI-powered intelligence, obviously, that is going to be the future, and definitely we see a lot of benefits out of it, and reducing the downtime and definitely providing ROI. Business alignment, we talked a lot about it, but I just want to give this 360-degree view. So this is really helping customers to get a 360-degree view of the system, not only from a technical perspective, but business, right? So it's all, what are the things we can measure from business side? It's all the business functions and outcomes, like how many orders placed. So the order funnel, like where the customers are dropping, right? When they come and watch and they're entering the details, but they're not making a payment. They're not converting. So get that visibility, why that is happening. Is it because of we don't have controls in the right place or buttons are not working? So something like that. And next about the customer journey map, the CX and UX. So that's the next level of getting the visibility into what users are doing. And below that, we have an API layer, measure the golden signals for it. And below the API, we have a connector layer, all the middleware, where messaging platform and everything measure the context propagation and resilience. Because most of the time, we do it through APIs, but if it's asynchronous, we miss the context. So we don't know when the message callbacks came in and how it's getting propagated. And after that, the downstream database where the data resides. And finally, underlying infrastructure. So this gives you the funnel of 360-degree view. When the business complains about users' orders are not going through, there is a sudden drop in the orders. We know that it's because of a high CPU or a pod crash from there. So if you get this chain of information, so we can clearly correlate where the problem is that is affecting the business. So with this, we can have a reliable, scalable, secure platform. But that's not going to give you 100%. So start having the FinOps visibility, saw a couple of sessions, and also DevSecOps. That is very important, how your feature rollout pipeline looks like, right? So this gives you a 360-degree view of the complete engineering and business ecosystem. So this concludes with like future is very collaborative, definitely not between us and also with the AI agents, definitely for better reliability and reduction in toil and the continuously learning and improve the system. Thank you so much for being a wonderful audience. So for any questions, feel free to read. Any questions? Thank you again.
venture?